Hello students, myself Mrs. Bhavna Mukesh Vyas. Welcome all of you to this session of nanomaterial. So today in this session I'll be covering the structure, properties and applications of graphene. Graphene is a newly added allotrope in the carbon family. So welcome to the carbon family. Graphene is one of the most promising nanomaterial. It is also called as a wonder material. Now why so? Because of its application in the wide areas. So but before going to the application, studying the structure and properties, let us see that who discovered that graphene. In 2004, graphene was discovered by two physicists, Andrew Game and Konstantin Novoselov, at University of Manchester while doing a simple but groundbreaking experiment. And what is graphene? So graphene can be think, or we can view it as a single layer of graphite. We know what is graphite. So it is just, if you imagine that if you are holding a single layer of graphite, then that single layer, which is a single atom thick layer of tightly bonded carbon atoms arranged in flat hexagonal honeycomb like structure, is nothing but graphene. So as far as structure is concerned, the structure is a honeycomb like structure. It's written, this we can see that this is just a single layer of graphite, and all carbon present here, all carbon atoms present here are sp2 hybridized. So as far as dimensionality is considered, it's a two-dimensional structure and the atomic thickness is equal to 0.345 nanometer. So this is what about the structure. So the structure of graphene is this. So having honeycomb like structure, hexagonal structure and single atom thick layer. Okay. So now if it is so important, let's see what are the properties, or what are the key properties that it consists of. So mainly we'll study the physical properties like its strength, toughness, surface area, chemical properties, electrical properties and optical properties, and we'll see how these properties can be utilized to get the various technology, or to get the various product based on these properties, and how then we can prove that how it is a wonderful material and why it is so much promising material. So as far as, let's start with the physical properties of graphene first. So it is one of the thinnest material. Why it is one of the thinnest material? Because it is just only one carbon atom thick. That's why it is one of the thinnest material. Then if we want to stretch it, if we stretch it up to 20 to 25% of initial size without breaking it, it can get stretched. So it's a flexible as well. So it's a flexible material. Very tough material. It is the toughest two-dimensional materials. It is 200 times stronger than steel. So it's very hard, or even it is more tougher or harder than diamond of the same dimension. It's having high strength. So and if we weigh it, then it just 0.77 milligram per meter square. So very lightweight. Then since it's having single two-dimensional sheet, it's having highest surface area to volume ratio. Then it's highly impermeable. So even the helium atom cannot pass through it. So it's highly impermeable. As far as its conductivity is concerned, thermal conductivity, it's a perfect thermal conductor. And it's and why we are calling it as a perfect thermal conductor? Because it conducts heat in all directions, hence it is an isotropic conductor, and the measured thermal conductivity is also very high, which is in the range of around 3000 to 5000 watt per meter per Kelvin at room temperature, which is among the which is among the highest of any other known material. So this is even graphite, if we consider its thermal conductivity is lesser than this, and as well as diamond. So other allotropes. So this is what about the physical properties we discussed. And as far as chemical properties are concerned, it's an inert material. It doesn't readily react with other atoms, even though all the graphene atoms are exposed to the environment because it is just a single sheet. So it's an inert material but does not readily react with other atoms, but can get functionalized so by various some chemical groups. So if when functionalized with fluorine, it is called as fluorinated graphene. When with oxygen, it is called as graphene oxide. So it can result in different materials. So because it absorbs some different atoms and molecules which can lead or which can change its electronic properties. So functionalized graphene will have different properties which can which we can change and then can be utilized for some specific purpose. So few research papers are based on this chemical properties of graphene as well, how we can alter its properties by attaching the functional group on the graphene. Then as far as its electrical properties are concerned, it's high electrical conductivity, it's having high electrical conductivity, and which we generally, it is said that it's million times than that of copper, million times high than that of copper. And even the intrinsic mobility is almost 100 times more than that of silicon. It's having lower resistivity at room temperature. And if there are some methods which can turn the graphene into a superconductor, so and it can carry then the electricity with 100% of efficiency, so it can become a superconductor as well. Although the graphene, the fastest and the most efficient conductor, but it cannot be readily used to make the transistor. But we can make the transistor, but we have to adopt some methods which will open up the band gap, as it doesn't have band gap. So we have to adopt some methods which open up the band gap and then can be utilized. Okay. So as far as optical properties are concerned, it's highly transparent material, extremely thin as well as highly transparent. Why highly transparent? Because 98% of visible light, white light, can pass through the graphene. So it's which makes it transparent. And when we combine these optical properties with the electronic properties, then theoretically it can be used to make a very efficient solar cells. And so this transparent property can be utilized for various products, like it can be used to make a transparent conductors and all. So this is what about the properties. Now when we say that if so many properties it is having, then let's see what are the potential use of graphene, what are the potential uses or applications of graphene. But before going to the graphene, let me tell you one thing, that graphene, when it was discovered in 2004 by those two scientists and who received a Nobel Prize on that in 2010, at that time that experiment was very simple, like how graphene can be synthesized. Let's say if I want to synthesize graphene, how it can be synthesized. It's a nanomaterial, how it can be synthesized. So there are 2-3 methods by means of which graphene can be synthesized. So the very first one method is a graphene surface is exfoliated with adhesives which can give thin flakes of graphene. Then another way is graphite is abraded, such as when drawing with a pencil, and then the graphene one can make. So likewise graphene can be synthesized, and some chemical methods are also there. So let's go for the application part. So once we get the graphene, where it can be used, basically always the application is always related with the structure or mainly the properties of the material. So as far as graphene is concerned, we have seen in the properties that it is highly impermeable. It doesn't allow the helium atom also to pass through it. So water, it can be used as a filter can be used as a filter in the water filtration system, wherein it will allow only water to pass through it and not other liquids and gases. Then it can be the property like transparency and conductivity of graphene can be used for the touch screens, then displays, but these methods are little bit more expensive than the current one. Then even in the electronic devices, graphene can be used to make a very fast transistor, and even it is touted as silicon successor. And but however, its conductivity cannot be switched off as silicon can. So these are the few applications I am discussing. Then if we go in little bit more depth, then we can see that the potential application of graphene is to make sensors. So graphene as a sensor, why? Because it is ultra sensitive, as every atom is exposed to its surrounding, allowing it to sense the changes in the surrounding can be utilized to make a sensor. For example, one can make use of graphene to produce smart food packaging that detects the atmospheric changes caused by decaying the food. Even it can be used to protect the crops, as farmers would be able to monitor the existence of any harmful gases and would be able to determine the ideal areas for the growth of certain crops depending on the atmospheric conditions. So all these will be in the form of sensors. So graphene can be used as a sensor to monitor the stresses and strains in the constructional components. Then it can be used to detect the biological agents like drugs in our body. Then it can be used to detect the light and can be used in camera. So it can be used as a sensor in wide areas. Hence even it is also as I told you that it is a wonder material. Why? Because it is a multifunctional material. What do you mean by multifunctional material? It means that if I am having one sensor of graphene, it can be utilized for different areas as a sensor. So it is a multifunctional material and allows to create a micrometer sized sensor. So this is that's why the reason is it is because of its potential use in different areas, or we can say applications of graphene in different industries will be is very promising. Hence the graphene is a most promising nano material. And let's do one thing. Let's see actually right now any product is there in the market. Let's see that. But before that, let me discuss two more uses. It can be used in medical field as a drug delivery. So some biomedical applications are also there for graphene, and so including the drug delivery, or you can say cancer therapy, etc. But before using it, its toxicity profile must be investigated. So that should be done. So it's under it's not yet commercialized, but can be used. Then can be used in the batteries and supercapacitors as a substitute for graphite that can store more energy, which can charge faster, like that. Okay, so let's see which products are there right now in the market. If we see this racket, it's a tennis racket which is available on Amazon, which is called as Head-U Tech Graphene Instinct tennis racket, and which came here as a product in 2013, and they have used the graphene coating on the shaft to make it stronger and better controlled racket. Then Huawei Mate 20X smartphone uses graphene film technology for the heat management purpose. So even they have used, this company, smartphone company, have used this graphene film. Then the Cardia used the biosensors. Then Ford, a car company, used graphene reinforced foam covers for noisy component in its cars. So these are the various products which are right now available in the market, and still there are many more products which will come in near future. So thank you very much for listening this video.